Welcome to the Phenomenological Alliance channel. In this video, we will discuss the issue of dividing knowledge between the natural and humanistic sciences.
After the Renaissance, a strict division into natural and humanistic sciences was established. It is considered that the field of knowledge is essentially divided into what can be objectively quantified and what cannot be objectively quantified. For example, the rules of warm and cold colors, which are studied through aesthetic color circles, are considered something that concerns subjective, artistic experiences. On the contrary, physics, as a science of objective natural laws, is concerned with measuring and quantifying the actual temperatures of the spectrum. This attitude can be summarized by the statement of the British physicist William Thomson, better known as Lord Kelvin.
I often say that when you can measure what are you speaking about, and expressed it in numbers, you know something about it. But when you cannot express it in numbers, your knowledge is of a meager and unsatisfactory kind. It may be the beginning of knowledge, but you have scarcely, in your thoughts, advanced to the stage of science, whatever the matter may be.
This perspective gained its greatest momentum through quantum physics, with a focus on the complex mathematical analyses of the behavior of microscopic particles. For example, it has been observed that in blacksmithing, iron undergoes a color transformation, starting as dark, then turning reddish, and finally acquiring an orange hue. Eventually, red-hot iron emits white light. Mathematical analysis of this occurrence contributed to the formulation of Wien's displacement law. It asserts that the black-body radiation curve for various temperatures will peak at wavelengths inversely proportional to the temperature. As the temperature increases, the body emits progressively more orange, yellow, green, and blue light. In practical terms, black-body radiation suggests that blue is the warmest color and red is the coldest. This conclusion contradicts the aesthetic laws of color, where red is traditionally associated with warmth and blue is seen as cold.
Let's illustrate with practical examples how the research fields of humanistic sciences, such as psychology and aesthetics, are inherently intertwined with the field of physics as a natural science. External experience suggests that dark surfaces react more intensely to temperature differences. For instance, when I shine laser light on my index finger, I don't notice any temperature differences. However, if I coat my index finger with soot, the sensation of temperature differences intensifies. Within seconds, I feel a burning sensation on my finger. The same principle applies to sources of coldness. When our hands are cold, we rarely perceive snow as a source of cold. Yet, if we coat our warm hands with soot, the sensation of cold intensifies. For this reason, black ice forms on surfaces exposed to the clear night sky, even when the ambient temperature does not drop below freezing. All chromatic colors are lighter than black and darker than white. Blue is darker than yellow. Consequently, blue surfaces heat up or cool down faster than yellow ones. Let us note that in studying natural phenomena, we establish a point of comparison. For example, when we look at an illuminated red square on a white background for a brief period, upon closing our eyes, in front of our eyes we see a complementary image, a turquoise square against a black background. If the red square is strongly illuminated, we observe the appearance of the complementary color even without closing our eyes, simply by turning off the light source. This psychological effect highlights how the intense experience of an image in light evokes the perception of a complementary image in darkness. But this phenomenon isn't merely a subjective perception of reality. Exactly the same phenomenon is observable in the experiment of complementary shadow. In the case of the appearance of the complementary image, the psychovisual effect refers to real external phenomena. A similar complementary principle applies in thermodynamics. When we touch metal with our hands, it feels colder than the piece of wood, even though both metal and wood are at the same temperature. This can be demonstrated through an experiment. Submerge left hand in cold water and right hand in warm water. Then place both hands in lukewarm water. We'll feel that the water is warm on our left hand and cold on our right hand. These observations led to the formulation of the so-called zeroth law of thermodynamics, which states, if two bodies are in thermal equilibrium with a third body, then they are in thermal equilibrium with each other. This principle serves as a reminder that despite our sensory perceptions, objects like a piece of iron and a piece of wood have the same environmental temperatures, or that our senses don't measure absolute temperature and heat flow, but rather make their own judgments and measurements, contradicting the objective laws of nature. According to the second law of thermodynamics, which dictates that heat flows spontaneously from a warmer to a colder body, this simple experiment suggests that the metal removes heat from the hand faster than the body heat can replace it. Consequently, the hand's temperature decreases. However, such an attitude overlooks the straightforward fact that the metal heats up upon contact. After being exposed to warm or cold water, the right and left hands, now at different temperatures, interact differently with lukewarm water. A warm hand heats the lukewarm water, whereas a cold hand cools it down. In the same way, upon contact, our hands heat up a piece of iron faster than a piece of wood. This quicker attainment of temperature equilibrium leads to our perception that iron feels colder than wood. Our senses inform us that wood equalizes temperature with our hands more slowly compared to metal. We represent the complementary pole of external reality. For the public to accept the second law of thermodynamics, people had to be persuaded through experiments that their perception was false because it contradicted the principles of heat transfer. The application of the second law of thermodynamics to real-life situations led to the assertion that even cold bodies emit heat. The second law of thermodynamics does not describe human perception, but postulates reality. In 1800, William Herschel studied the thermal radiation of solar light. By measuring the temperatures of spectral colors, Herschel observed that the most significant heating effect occurred beyond the visible red, specifically in the region of the black surface. Additionally, there was a gradual decrease in the heating effect from the red to the blue end of the spectrum. In the same way, aesthetic experience categorizes colors into warm and cold tones, with orange-red shades perceived as warm compared to violet-blue ones. The assertions based on the formula of black-body radiation, stating that blue is the warmest color and red the coldest, overlook the naked truth that these judgments apply to hot bodies. On the contrary, when objects heat up, the blue surface warms rapidly, much like a piece of metal. Consequently, in comparison to our body temperature, we perceive the blue surface as cold. The aesthetic or psychological division of colors aligns with the temperatures of colored surfaces that we can measure externally.
Today it is often claimed that, for example, mathematics, or physics are objective sciences, while aesthetics is seen as dealing with individual artistic experiences. It is commonly argued that harmony is an aesthetic concept of balance that does not refer to natural laws. Phenomenology, as a science of conscious experience, rejects the division of knowledge into subjective and objective. The experience of individual consciousness cannot be divided into subjective and objective experiences. There is no possibility that an imagined external truth bypasses human consciousness and avoids non-individual expression. External facts become the subject of science only when they become the subject of thinking, namely when they present themselves to individual consciousness through conceptual interconnections. All factual rules, including the rules of aesthetics, can be observed in external nature as objective laws. Conversely, the facts we recognize in external nature can help us better understand ourselves. Therefore, the phenomenological approach rejects the division into natural and humanistic sciences, but recognizes the field of knowledge as indivisible.
When observing natural phenomena, we can often witness contrasts such as light versus dark, heat versus cold, or the north versus south magnetic pole. We also observe that nature often behaves by balancing opposites. Colors appear as transitions between light and darkness, temperature balance in the interplay between heat and cold, and similar. In the next few videos, let us explore whether the principle of balance can also be observed in the realm of mechanical forces, in the realm of motion and gravity.